There's been a lot of talk about an AI bubble. From our vantage point, we see something very different. As a reminder, Nvidia is unlike any other accelerator. We excel at every phase of AI, from pre-training and post-training to inference. And with our 2-decade investment in CUDA-X acceleration libraries, we are also exceptional at science and engineering simulations, computer graphics, structured data processing, to classical machine learning. The world is undergoing 3 massive platform shifts at once. The first time since the dawn of Moore's Law. Nvidia is uniquely addressing each of the 3 transformations. The first transition is from CPU general purpose computing to GPU accelerated computing, as Moore's Law slows. The world has a massive investment in non-AI software, from data processing to science and engineering simulations, representing hundreds of billions of dollars in cloud computing spend each year. Many of these applications, which ran once exclusively on CPUs, are now rapidly shifting to CUDA GPUs. Accelerated computing has reached a tipping point. Secondly, AI is also reached a tipping point and is transforming existing applications while enabling entirely new ones. For existing applications, generative AI is replacing classical machine learning in search ranking, recommender systems, ad targeting, click-through prediction to content moderation, the very foundations of hyperscale infrastructure. That is GEM, a foundation model for ad recommendations trained on large-scale GPU clusters, exemplifies this shift. In Q2, Meta reported over a 5% increase in ad conversions on Instagram and 3% gain on Facebook feed, driven by generative AI-based GEM. Transitioning to generative AI represents substantial revenue gains for hyperscalers. Now a new wave is rising. Agentic AI systems, capable of reasoning, planning, and using tools, from coding assistants like Cursor and Quad Code to radiology tools like iDoc, legal assistants like Harvey, and AI chauffeurs like Tesla FSD and Waymo. These systems mark the next frontier of computing. The fastest growing companies in the world today: OpenAI, Anthropic, xAI, Google, Cursor, Lovable, Replit, Cognition AI, Open Evidence, Abridged, Tesla, are pioneering agentic AI. So there are 3 massive platform shifts. The transition to accelerated computing is foundational and necessary, essential in a post-Moore's Law era. The transition to generative AI is transformational and necessary, supercharging existing applications and business models. And the transition to agentic and physical AI will be revolutionary, giving rise to new applications, companies, products, and services. As you consider infrastructure investments, consider these 3 fundamental dynamics. Each will contribute to infrastructure growth in the coming years. NVIDIA is chosen because our singular architecture enables all 3 transitions, and does so for any form and modality of AI across all industries, across every phase of AI, across all of the diverse computing needs in a cloud, and also from cloud to enterprise to robots. One architecture. Bashia, back to you. And we were planning for a big year. We've seen for some time the 3 transitions that I spoke about just a second ago: accelerated computing from general purpose computing. And it's really important to recognize that AI is not just agentic AI, but generative AI is transforming the way that hyperscalers did the work that they used to do on CPUs. Generative AI made it possible for them to move search and recommender systems and, ad recommendations and targeting. All of that has been moved to generative AI, and it's still transitioning. And so whether you installed NVIDIA GPUs for data processing, or you did it for generative AI for your recommender system, or you're building it for agentic chatbots and the type of AIs that most people see when they think about AI, all of those applications are accelerated by NVIDIA. And so when you look at the totality of the spend, it's really important to think about each one of those layers. They're all growing. They're related, but not the same. But the wonderful thing is that they all run on NVIDIA GPUs. Simultaneously, because the quality of the AI models are improving so incredibly, the adoption of it in the different use cases, whether it's in code assistance, which NVIDIA uses fairly exhaustively, and we're not the only one. I mean, the fastest growing application in history, combination of Cursor and Claude Code and Code OpenAI's Codex and GitHub Copilot. These applications are the fastest growing in history. And it's not just used for software engineers. It's used because of vibe coding, it's used by engineers and marketeers all over companies, supply chain planners all over companies. And so I think that that's just one example, and the list goes on, whether it's open evidence and the work that they do in healthcare, or the work that's being done in digital video editing, Runway. And I mean, the number of really, really exciting startups that are taking advantage of generative AI and agentic AI is growing quite rapidly. And not to mention, we're all using it a lot more. And so all of these exponentials, not to mention, just today I was reading a text from Demis, and he was saying that pre-training and post-training are fully intact, and Gemini 3 takes advantage of the scaling laws and received a huge jump in quality performance, model performance. And so we're seeing all of these exponentials kind of running at the same time, and just always go back to first principles and think about what's happening from each one of the dynamics that I mentioned before: general purpose computing to accelerated computing, generative AI replacing classical machine learning, and of course, agentic AI, which is a brand new category. In each generation, from Ampere to Hopper, from Hopper to Blackwell, Blackwell to Rubin, a part of the data center increases. And Hopper generation was probably something along the lines of 20 to 25. Blackwell generation, Grace Blackwell particularly, is probably 30, say 30 plus or minus. And then Rubin is probably higher than that. And in each one of these generations, the speed up is X factors. And therefore their TCO, the customer TCO, improves by X factors. And the most important thing is, in the end, you still only have 1 gigawatt of power. 1 gigawatt data centers, 1 gigawatt power. And therefore, performance per watt, the efficiency of your architecture, is incredibly important. And the efficiency of your architecture can't be brute forced. There is no brute forcing about it. That 1 gigawatt translates directly, your performance per watt translates absolutely directly to your revenues, which is the reason why choosing the right architecture matters so much now. The world doesn't have an excess of anything to squander. And so we have to be really, really, we use this concept called co-design across our entire stack, across the frameworks and models, across the entire data center, even power and cooling optimized across the entire supply chain in our ecosystem. And so each generation, our economic contribution will be greater, our value delivered will be greater, but the most important thing is our energy efficiency per watt is going to be extraordinary every single generation. With respect to growing into continuing to grow, our customers' financing is up to them. We see the opportunity to grow for quite some time. And remember, today, most of the focus has been on the hyperscalers. And one of the areas that is really misunderstood about the hyperscalers is that the investment on NVIDIA GPUs not only improves their scale, speed, and cost from general purpose computing. That's number one, because Moore's law scaling has really slowed. Moore's law is about driving costs down. It's about deflationary cost, the incredible deflationary cost of computing over time, but that has slowed. Therefore, a new approach is necessary for them to keep driving the cost down. Going to NVIDIA GPU computing is really the best way to do so. The second is revenue boosting in their current business models. Recommender systems drive the world's hyperscalers. Every single, whether it's, watching short form videos or recommending books or recommending the next item in your basket to recommending ads to recommending news it's all about recommenders. The internet has trillions of pieces of content. How could they possibly figure out what to put in front of you in your little tiny screen unless they have really sophisticated recommender systems to do so? Well, that has gone generative AI. So the first two things that I just said, hundreds of billions of dollars of CapEx is going to have to be invested, is fully cash flow funded. What is above it, therefore, is agentic AI. This is revenue, is net new consumption, but it's also net new applications. And some of the applications I mentioned before, but these new applications are also the fastest growing applications in history. Okay, so I think that you're going to see that once people start to appreciate what is actually happening under the water, if you will, from the simplistic view of what's happening to CapEx investment, recognizing there's these three dynamics. And then lastly, remember, we were just talking about the American CSPs. Each country will fund their own infrastructure. And you have multiple countries, you have multiple industries. Most of the world's industries haven't really engaged agentic AI yet, and they're about to. All the names of companies that we're working with, whether it's autonomous vehicle companies or digital twins for physical AI for factories, and the number of factories and warehouses being built around the world, just the number of digital biology startups that are being funded so that we could accelerate drug discovery. All of those different industries are now getting engaged, and they're going to do their own fundraising. And so don't just look at the hyperscalers as a way to build out for the future. You got to look at the world. You got to look at all the different industries, and enterprise computing is going to fund their own industry. The depth and the breadth of supply chain that Nvidia has. The reason why our entire customer base can rely on us is because we've secured a really resilient supply chain, and we have the balance sheet to support them. When we make purchases, our suppliers can take it to the bank. When we make forecasts and we plan with them, they take us seriously because of our balance sheet. We're not making up the offtake. We know what our offtake is, and because they've been planning with us for so many years, our reputation and our credibility is incredible. And so it takes really strong balance sheet to do that, to support the level of growth and the rate of growth and the magnitude associated with that. So that's number one. The second thing, of course, we're going to continue to do stock buybacks. We're going to continue to do that. But with respect to the investments, this is really, really important work that we do. All of the investments that we've done so far, period, is associated with expanding the reach of CUDA, expanding the ecosystem. If you look at the work the investments that we did with OpenAI, it's, of course, that relationship we've had since 2016. I delivered the first AI supercomputer ever made to OpenAI. And so we've had a close and wonderful relationship with OpenAI since then. And everything that OpenAI does runs on NVIDIA today. So all the clouds that they deploy in, whether it's training and inference, runs NVIDIA, and we love working with them. The partnership that we have with them is one so that we could work even deeper from a technical perspective, so that we could support their accelerated growth. This is a company that's growing incredibly fast. And don't just look at what is said in the press. Look at all the ecosystem partners and all the developers that are connected to OpenAI. And they're all driving consumption of it. And the quality of the AI that's being produced, huge step up since a year ago. And so the quality of response is extraordinary. So we invest in OpenAI for a deep partnership in co-development to expand our ecosystem and support their growth. And of course, rather than giving up a share of our company, we get a share of their company. And we invested in them in one of the most consequential once-in-a-generation company that we have a share of. And so I fully expect that investment to translate to extraordinary returns. Now, in the case of Anthropic, this is a first time that Anthropic will be on NVIDIA's architecture. The first time Anthropic will be on NVIDIA's architecture is the second most successful AI in the world in terms of total number of users. But in enterprise, they're doing incredibly well. Claude Code is doing incredibly well. Claude is doing incredibly well all over the world's enterprise. And now we have the opportunity to have a deep partnership with them and bringing Claude onto the NVIDIA platform. And so what do we have now? NVIDIA's architecture, taking a step back, NVIDIA's architecture, NVIDIA's platform is the singular platform in the world that runs every AI model. We run OpenAI, we run Anthropic, we run xAI. Because of our deep partnership with Elon and xAI, we were able to bring that opportunity to Saudi Arabia, to the KSA, so that Huang could also be a hosting opportunity for xAI. We run xAI, we run Gemini, we run thinking machines. Let's see, what else do we run? We run them all. And so not to mention, we run the science models, the biology models, DNA models, gene models, chemical models, and all the different fields around the world. It's not just cognitive AI that the world uses. AI is impacting every single industry. And so we have the ability through the ecosystem investments that we make to deeply partner on a technical basis with some of the best companies, most brilliant companies in the world. We're expanding the reach of our ecosystem, and we're getting a share and investment in what will be a very successful company, oftentimes once in a generation company. And so that's our investment thesis. Basically, before you start generating answers, you have to read a lot, basically, long context. And it could be a bunch of PDFs, it could be watching a bunch of videos, studying 3D images, so on and so forth. You have to absorb the context. And so CPX is designed for long context type of workloads. And its perf per dollars is excellent. There are three scaling laws that are scaling at the same time. The first scaling law, called pre-training, continues to be very effective. And the second is post-training. Post-training basically has found incredible algorithms for improving AI's ability to break a problem down and solve a problem step by step. And post-training is scaling exponentially. Basically, the more compute you apply to a model, the smarter it is, the more intelligent it is. And then the third is inference. Inference, because of chain of thought, because of reasoning capabilities, AIs are essentially reading, thinking, before it answers. The amount of computation necessary as a result of those three things has gone completely exponential. I think that it's hard to know exactly what the percentage will be at any given point in time and who. But of course, our hope is that inference is a very large part of the market, because if inference is large, then what it suggests is that people are using it in more applications and they're using it more frequently. And that's, we should all hope for inference to be very large. And this is where Grace Blackwell is just an order of magnitude better, more advanced than anything in the world. The second best platform is H200. And it's very clear now that GB200, GB300, because of NVLink 72, the scale of network that we have, achieve, and you saw, and Colette talked about in the semi-analysis benchmark, it's the largest single inference benchmark ever done. And GB200, NVLink 72 is 10 to 15 times higher performance. And so that's a big step up. It's going to take a long time before somebody is able to take that on. And our leadership there is surely multi-year. Yeah. And so I'm hoping that inference becomes a very big deal. Our leadership in inference is extraordinary. When you're growing at the rate that we are and the scale that we are, how could anything be easy? What NVIDIA is doing obviously has never been done before. And we've created a whole new industry. On the one hand, we are transitioning computing from general purpose and classical or traditional computing to accelerated computing and AI. That's on the one hand. On the other hand, we created a whole new industry called AI factories. The idea that in order for software to run, you need these factories to generate it, generate every single token instead of retrieving information that was pre-created. And so I think this whole transition requires extraordinary skill, and all the way from the supply chain. Of course, the supply chain we have much better visibility and control over because obviously we're incredibly good at managing our supply chain. We have great partners that we've worked with for 33 years, and so the supply chain part of it, we're quite confident. Now, looking down our supply chain, we've now established partnerships with so many players in land and power and shell and of course financing. These things, none of these things are easy, but they're all tractable and they're all solvable things. And the most important thing that we have to do is do a good job planning. We plan up the supply chain, down the supply chain. We've established a whole lot of partners, and so we have a lot of routes to market. And very importantly, our architecture has to deliver the best value to the customers that we have. And so at this point, I'm very confident that NVIDIA's architecture is the best performance per TCO. It is the best performance per watt, and therefore for any amount of energy that is delivered, our architecture will drive the most revenues. And I think the increasing rate of our success, I think that we're more successful this year at this point than we were last year at this point. The number of customers coming to us and the number of platforms coming to us after they've explored others is increasing, not decreasing. And so I think I think all of that is just, all the things that I've been telling you over the years are really coming true and or becoming evident. Remember that we plan, we forecast, we plan, and we negotiate with our supply chain well in advance. Our supply chain have known for quite a long time our requirements, and they've known for quite a long time our demand, and we've been working with them and negotiating with them for quite a long time. And so I think the recent surge, obviously quite significant, but remember our supply chain has been working with us for a very long time. And so in many cases, we've secured a lot of supply for ourselves, because obviously they're working with the largest company in the world in doing so, and we've also been working closely with them on the financial aspects of it and securing forecasts and plans and so on and so forth. So I think all of that has worked out well for us. You're not competing against teams. As a company, you're competing against teams, and there just aren't that many teams in the world who are extraordinary at building these incredibly complicated things. Back in the Hopper day and the Ampere days, we would build one GPU. That's the definition of an accelerated AI system. But today, we've got to build entire racks, three different types of switches: a scale up, a scale out, and a scale across switch. And it takes a lot more than one chip to build a compute node anymore. Everything about that computing system, because the AI needs to have memory. AI didn't used to have memory at all. Now it has to remember things. The amount of memory and context it has is gigantic. The memory architecture implication is incredible. The diversity of models, from mixture of experts to dense models to diffusion models to autoregressive, not to mention, biological models that obey the laws of physics. The list of different types of models have exploded in the last several years. And so the challenge is the complexity of the problem is much higher. The diversity of AI models is incredibly large. And so this is where, if I will say the 5 things that makes us special, if you will, the first thing I would say that makes us special is that we accelerate every phase of that transition. That's the first phase. That CUDA allows us to have CUDA X for transition from general purpose accelerated computing. We're incredibly good at generative AI. We're incredibly good at agentic AI. So every single phase of that, through every single layer of that transition, we are excellent at. You can invest in one architecture, use it across the board. You can use one architecture and not worry about the changes in the workload across those three phases. That's number one. Number two, we're excellent at every phase of AI. Everybody's always known that we're incredibly good at pre-training. We're obviously very good at post-training, and we're incredibly good, as it turns out, at inference, because inference is really, really hard. How could thinking be easy? People think that inference is one shot and therefore it's easy. Anybody could approach the market that way. But it turns out to be the hardest of all, because thinking, as it turns out, is quite hard. We're great at every phase of AI, the second thing. The third thing is we're now the only architecture in the world that runs every AI model, every frontier AI model. We run open source AI models incredibly well. We run science models, biology models, robotics models. We run every single model. We're the only architecture in the world that can claim that. It doesn't matter whether you're autoregressive or diffusion-based. We run everything. And we run it for every major platform, as I just mentioned. So we run every model. And then the fourth thing I would say is that we're in every cloud. The reason why developers love us is because we're literally everywhere. We're in every cloud. We're in every, we could even make you a little tiny cloud called DGX Spark. And so we're in every computer. We're everywhere, from cloud to on-prem to robotic systems, edge devices, PCs, you name it. One architecture, things just work. It's incredible. And then the last thing, and this is probably the most important thing, the fifth thing, is if you are a cloud service provider, if you're a new company like Huang, if you're a new company like CoreWeave, Nscale, Nebius, or OCI for that matter, the reason why NVIDIA is the best platform for you is because our offtake is so diverse. We can help you with, it's not about just putting a random ASIC into a data center. Where's the offtake coming from? Where's the diversity coming from? Where's the resilience coming from? The versatility of the architecture coming from, the diversity of capability coming from. NVIDIA has such incredibly good offtake because our ecosystem is so large. So these five things, every phase of acceleration and transition, every phase of AI, every model, and of